Welcome back. In this lesson, we're going to take a look at a new feature introduced in vSphere 7, the ability for vSphere to support NVMe devices over fabrics. So, NVMe, we'll take a look at the enhancements that NVMe support provides, understand the configuration in ESXi for NVMe over both fiber channel as well as for over RDMA, describe the enhancements of the new pluggable storage architecture options, and also describe the purpose of the high performance plugin. So, NVMe, non-volatile memory express. This is a storage design for very high speed flash storage with multi-queuing capabilities for these NVM devices, typically over a PCI bus, which is for a local device, a standard practice. And we've been doing this in vSphere since vSphere 6.5. vSphere 7 introduces this concept called NVMe over fabrics. And we say over fabrics, that could mean fiber channel, or it could be NVMe over RDMA. Right? We also cover pluggable storage architecture because it offers a stack that supports a high performance plugin used specifically for NVMe devices on the SAN. It can also be used for NVMe devices that are local too. There's also hot add and hot remove capability of NVM devices provided your server supports that. And there's also support for devices that use RDMA or fiber channel like we just mentioned. So to take a look at the NVMe technologies in vSphere 7, there's support for the NVMe as a local device, which isn't new. That's been there since vSphere 6.5. That's just simply NVMe on a PCI bus. And then we have PCI Express, right? So PCIe bus. And then there's also our NVMe over RDMA. Basically, that's part of the NVMe over fabrics umbrella, right? So when we say NVMe over fabrics, it's over some kind of shared access. That fabric could be an RDMA based mechanism. In the case of the NVMe over fabrics with RDMA in vSphere, it is over RDMA. It's over RDMA over converged Ethernet, otherwise known as RoCE. And so this is using RoCE version 2, in fact, which offers lossless Ethernet options. So that's cool. You can use this over Ethernet with Ethernet switches, provided the switch ports offer lossless capabilities themselves. And then there's also NVMe over fiber channel, right? NVMe FC, as it's known, or actually FC NVMe to get that right. And then that's all for the fiber channel fabric as opposed to being over Ethernet. So in both cases, over on the left, we're looking at FC NVMe, an array that has NVMe devices, which then get mapped into what are called namespaces. A namespace in the NVMe parlance is basically the same kind of thing as a LUN, right? So you create a logical organization of the NVMe SSDs into namespaces, which are then presented to your servers. In the case on the left, they're presented over the fiber channel fabric. Now the catch here is the HBAs that are on the fiber channel fabric need to be able to speak the NVMe protocol. These aren't the standard SCSI commands that we're used to doing with, say, LUNs in a more traditional storage environment. These are HBAs that must be able to speak the NVMe protocol instead. So they'll maybe converge in that they can do both, but these are adapters that do and require to speak the NVMe protocol. Over on the right-hand side, we have NVMe over RDMA. So this is an array that is instead connected to an Ethernet network as opposed to being connected to a fiber channel fabric. So these NVMe devices are also organized into namespaces, just like they would be on the fiber channel side of things. Just like how you would do the same thing with fiber channel versus iSCSI, you'd form your devices into LUNs and present them either over fiber channel or over Ethernet. Here, we're taking those namespaces and presenting them over fiber channel, NVMe over fiber channel, or their NVMe over RDMA, right? Ethernet, not IP here, right? This is just an Ethernet network providing an Ethernet fabric essentially. And the catch here is that on these ESX servers, you need an adapter that knows the RDMA capabilities, right? Because with RDMA, remote direct memory access, you're basically taking data in the memory of, say, the ESX server and transferring it to the memory of your storage array. bypassing the other resources such as CPU, giving very high throughput with little latency, and taking full advantage of the high-speed multi-queuing capabilities of those NVMe devices, right? So we do need the high-speed network, we need to have lossless network, and we want a protocol that has very little overhead to get the throughput down to the devices as high as possible. So in terms of configuring all this, well, on NVMe for Fiber Channel, right? FC NVMe, right? This is a technology that maps the NVMe onto the Fiber Channel protocol. This is part of the NVMe over Fabrics. Data and your commands are transferred between the host computer and your target storage device. To access this FC NVMe storage, you must install Fiber Channel storage adapters that supports NVMe on the host. That's about all you have to do, though. It's just like having to install a Fiber Channel standard adapter, right? You plug the adapter into your ESXi host, and that's really about it. As long as it's on the, the standard support list, right? It's on our hardware compatibility list, as we like to call it, the HCL. As long as the NVMe capable adapter is in your host, it's on the VMware HCL, you're set as far as setting it up on the host, right? Everything else needs to be set on the storage side. So requirements, you need obviously a Fiber Channel array that supports NVMe. You need an NVMe controller on your storage array. You need to be running ESXi 7. And the hardware NVMe adapter on your host, this adapter is a Fiber Channel host adapter that supports NVMe protocols, right? And then as far as the maximums go, all right, so those aren't the same as a LUN, right? LUNs, as you may remember, we allowed 1,024 LUNs per host when it's a traditional LUN. With NVMe namespaces, it actually maxes at 32. You still have 4 paths per LUN as the standard, so 32 namespaces equates to 128 total paths. Now with NVMe over RDMA, which is over RDMA over Converged Ethernet, also known as RoCE, and we use RoCE version 2, which offers a lossless Ethernet network, the data exchange occurs at the memory level, bypassing OS and processor on both the array and on your ESXi host. So ESXi 7 is where we support RoCE version 2, which enables RDMA over that Ethernet network, and to access storage, the host uses an RDMA network adapter installed on the host and a software NVMe over RDMA storage adapter. So it's actually a couple steps involved. We'll take a look at those configuration settings in a few moments. The requirements for NVMe over RDMA using RoCE version 2, the NVMe storage array with the NVMe over RDMA transfer support, that's a requirement. You need an NVMe controller on your storage array, of course, and ESXi 7. Ethernet switches supporting a lossless network, and the network adapter on your ESXi host that supports RoCE version 2. Right, so it's a network adapter, but it needs to be a network adapter that supports RDMA. That's the catch, right? And it needs to be using RoCE version 2, the lossless Ethernet network. And then we need to create a software storage adapter, kind of like when you build an iSCSI software adapter, you have to create a virtual adapter. It ends up being HBA number 64, right? What's the same thing here? You need to create a software NVMe over RDMA adapter on your host. And same maximums as we saw with FC NVMe, it's 32 namespaces per host with 128 paths, because you have maximum of 4 paths, or we generally recommend 4 paths per namespace per host. So let's take a look after the break at the actual configuration. Setting up the NVMe over RDMA does involve a few more steps than setting up FC NVMe on an ESXi host. Like we said, FC NVMe is kind of like setting up any other Fiber Channel adapter on a host. You plug it in. As long as it's on the HCL, it'll work on that host and you're good, right? For the NVMe over RDMA, we need to create a software adapter. We need to make sure our RDMA capable settings are already configured. So take a quick break and we'll see you in a few minutes as we finish this lesson.